Hello, and welcome to our lesson on project execution and change management. In this segment, we will cover project execution, production, build stage. The next step in the execution phase is the production build stage involving the production or construction of the end item. Key activities in this stage encompass fabrication, testing, and strategic planning for the upcoming project phases. The initiation of system fabrication occurs upon the completion of sufficient design work, prompting the project manager's authorization for fabrication. Components, crafted by both the contractor and its suppliers, are assembled to form the final end item. Throughout this phase, the project manager continues to oversee the work, facilitate coordination among departments, and meticulously track expenditures and completed tasks against the established budget and master schedule. Principal management tasks include the release of work orders, ongoing monitoring, inspection, documentation of progress, comparison of planned versus actual outcomes, and the implementation of corrective measures. Shared responsibilities for these tasks fall upon both the project manager and the manufacturing or construction manager. In the realm of system fabrication, an unwavering focus on work quality prevails. While the direct responsibility for quality control of components and fabrication does not lie with the project manager, she bears the ultimate responsibility for the quality of the final system. Thus, it becomes imperative for the project manager to ensure that other managers involved in the production build stage adhere to a comprehensive quality plan, aligning with the project's quality objectives. System testing. Throughout the execution phase, a diverse array of tests is conducted on the end item system, categorized into 3 groups. These encompass tests executed by the contractor to validate that the system design meets requirements, is adhered to by the producer or builder, and tests performed by the user to ensure alignment with user requirements and contractual agreements. The quality plan defines the tests to be conducted, along with their criteria and conditions. The initial group of tests focuses on design verification. If any shortcomings in performance arise due to flawed or inadequate design, it necessitates a repetition of the design stage. To minimize the cost and time associated with repeating steps, these tests are strategically designed to detect problems at the earliest possible stage. Even with a flawless design, the second group of tests is indispensable. It verifies that builders faithfully followed the design, adhering to specifications in terms of components and workmanship. The third group involves verification tests, reviews, and audits performed by the customer. Their objective is to ensure the fulfillment of user requirements, the completeness and accuracy of test documentation. User personnel, unlike design engineers, may uncover difficulties in system operation or induce failures that were not identified in the initial tests. To mitigate the risk of redesigning the entire system due to faulty components, a sequential testing approach is recommended. Individual parts undergo testing first, followed by integration into components and subsequent testing to ensure compatibility. This process continues with the integration of components into subsystems, culminating in the testing of the entire system to validate its performance against requirements. Tests are conducted based on earlier developed system specifications and user requirements. The project manager assumes responsibility for the test plan and schedule, integrating them into the production build plan. Ensuring the availability of necessary resources for the tests, documenting test results comprehensively, and filing them for future reference are all overseen by the project manager. In the phased approach to project planning, the project plan's details are progressively filled in as information becomes available. Thus, during the production build phase, a comprehensive plan for implementation is crafted. Implementation involves the process of transitioning the system to the user, with the 2 key activities being system installation in the user's environment and user training for system operation. The project manager shoulders the responsibility of developing plans in advance, ensuring that the implementation stage aligns with or precedes the completion of system fabrication. These plans must guarantee the timely availability of necessary side items for user training, system installation, and operation. Commencing early in the project, ideally during the definition phase, planning for implementation should be substantially completed by the conclusion of the production build stage. The implementation strategy, particularly for replacing an existing system with a new one, should encompass various aspects. Approach for transitioning from the old system to the new system. Sequencing and scheduling of implementation activities. Acceptance criteria and a test plan facilitate customer sign-off on the system. Approach to phasing out the old system and introducing the new one. User training. Installation details, encompassing installation, checkout, and acceptance of the end item and side items. Site preparation details, addressing security, access, power, space, equipment, etc. While an initial implementation plan may have been outlined earlier as part of the project master plan, a more detailed plan is now prepared in collaboration with the customer to address all the aforementioned points. Concurrently, the contractor accumulates materials essential for training users in system operation and maintenance. While simple systems may require only a brief instruction pamphlet and a warranty, more complex systems necessitate a comprehensive and user-friendly training approach. For intricate systems, the requirements extend beyond basic materials, warranting extensive documentation. This includes lengthy manuals covering procedures, system operation, repair, and servicing, along with testing manuals, trainer manuals, training materials, simulators, schematics, drawings, special tools, servicing and support equipment. Much of the information incorporated into these manuals is derived from the comprehensive documentation created during the design stage. Crucial to the successful completion of a project is reaching a clear agreement with the customer regarding the closure process, specifically how and when the project will be deemed complete and the system acceptable. Misunderstandings on this aspect, such as ambiguous conditions like acceptance only after modification, can lead to indefinite project delays. To prevent such scenarios, the user requirements defined early in the project should ideally outline the conditions and criteria for customer acceptance of the system. This is the end of this segment of our lesson. In the next segment, we will discuss Executing Process Group. This course is presented to you by South Europe College. Thank you for listening and see you on our next segment.